it's time for us to learn the adiabatic process. Adiabatic means absolutely no heat transfer, and that is achievable when you have some kind of adiabatic wall. For example, here you can see that there is a clear-cut adiabatic wall being provided, and whatever process happens here, there is no heat transfer in and out of the system. Inside the system there can be heat transfer, maybe the heat lost by a gas will be taken by the heat by some other it is now time for us to start with adiabatic process. Adiabatic process means heat transfer is equal to 0. That is, our process will be supported by some external adiabatic wall or some arrangements by which we can actually ensure that there is no heat transfer in and out of the system. Now, during an adiabatic process, if I represent it in a PV diagram, it will be something like this: steeper than isothermal process, and I am representing it as 1, 2, and as I know, the area under this curve 1, 2 will definitely give me the work done by the graphical method. I need to find the work done by using the equation W is equal to integral PdV. So here PV is equal to gamma is a constant. This is the standard equation for an adiabatic process, where gamma represents the index of expansion or maybe compression, and it depends on the gas or the fluid that is being used during this particular process. For example, the adiabatic index or gamma for air is equal to 1.4. That's a standard value. Now, this gamma, it depends on the various gases or fluids that we are using in that particular process. So I can write here PV raised to gamma is equal to P1 V1 raised to gamma is equal to P2 V2 raised to gamma. All these values are going to be constant values. Now, same like the isothermal process, I am having a problem with P as the pressure is not going to be constant. Therefore, I am taking this equation, that is PV raised to gamma equal to P1 V1 raised to gamma, and therefore P is equal to P1 V1 raised to gamma by V raised to gamma. So I am substituting it out here. W is equal to integral 1 to 2. Instead of P, I am giving P1 V1 raised to gamma by V raised to gamma into dV. Again, this term P1 V1 raised to gamma. See, P1 V1 raised to gamma is equal to P2 V2 raised to gamma, which is equal to a constant. Therefore, this value is a constant value. So I can write it as P1 V1 raised to gamma integral 1 to 2 dV by V raised to gamma. That means my equation for work done will become P1 V1 raised to gamma. I am taking this integral dV by V raised to gamma. What is integral 1 to 2? 1 by V raised to gamma into dV. This becomes, this term will be equal to, what is it? V raised to minus gamma plus 1 by minus gamma plus 1. So I am applying it here. This is equal to V raised to minus gamma plus 1 divided by minus gamma plus 1 in the range of V1 to V2. I hope this is not interfering in our derivation. Now this one, again I can apply the limits out here. For that I am again taking W is equal to P1 V1 raised to gamma by, I am taking this outside, minus gamma plus 1, minus gamma plus 1, I am writing 1 is plus, this is minus gamma, this term is taken outside, which is now equal to V raised to minus gamma plus 1 in the range V1 to V2. Now what I am applying is, this is equal to, say here P1 V1 raised to gamma by 1 minus gamma, this into this term will become V2 raised to gamma plus, minus gamma plus 1 minus V1 raised to minus gamma plus 1. Now you know that P1 V1 raised to gamma is equal to P2 V2 raised to gamma, right? So I am inserting this, or I am just multiplying this term with both these values which are inside the bracket. So it becomes, see, P1 V1 raised to gamma is equal to P2 V2 raised to gamma. So I am writing, instead of P1 V1 raised to gamma, P2 V2 raised to gamma into V2 raised to minus gamma plus 1. Okay, I am multiplying P1 V1 raised to gamma inside, but since P1 V1 raised to gamma is equal to P2 V2 raised to gamma, since this term is V2, I am taking it in terms of 2, P2 and V2 raised to gamma, minus this I am taking it same, P1 V1 raised to gamma into V1 raised to minus gamma plus 1. This whole term divided by 1 minus gamma. Now what will happen to this? Okay, this can be again written as, okay, here you can see V2 into V2 raised to gamma minus 1. See, for example, this one, V2 raised to gamma into V2 raised to minus gamma plus 1. So what happened? This will be equal to V2 raised to, this is multiplication, therefore it is gamma plus minus gamma plus 1. Therefore gamma and gamma will get cancelled, so it will be just V2. Therefore I can write this as P2 V2 minus, this will also happen the same way, because this will be equal to P1 into, like, V1 raised to gamma into V1 raised to gamma plus 1. Therefore gamma plus minus gamma plus 1, therefore gamma will get cancelled and this will become P1 V1 by 1 minus gamma. So this is a standard equation for W. This can be also written as, this is one thing, this can be written like this, W is equal to P2 V2 minus P1 V1 by 1 minus gamma. Or I can write it as W is equal to, I'm just changing it to P1 V1 minus P2 V2. Therefore the lower term will become gamma minus 1. So that is the equation for work done for an adiabatic process. Again, if I take out this P1 V1 outside, because P1 V1 is equal to P2 V2, then I can write W is equal to P1 V1 by gamma minus 1 into 1 minus P2 by P1 the whole raised to gamma minus 1 by gamma. This is another equation for work done. Here you can see that it is in terms of the pressure ratio P2 by P1 raised to gamma minus 1 by gamma. So all these equations can be used in our problems, where you will be using the basic equation also to find, maybe P1 and V1 will be there, but P2 will not be there. So you can use these equations and solve for the value of P2.